Good afternoon, everybody. Welcome to Scale. This is Access Self-Hosted Services Security from Anywhere. Please welcome Alex Kretzschmar.
Thank you. Yeah, I have the Brittany mic on today. I have some other of Brittany's features too, but there you go. Apologies if my voice cracks during this. I was on the booth yesterday all day in that very loud exhibition hall, and I don't have much voice left, so fingers crossed it holds out. So I know some of you in the audience are already Jupiter Broadcasting fans. Hands up if that's you. Awesome. Thank you so much for coming. My name's Alex. I do a podcast called Self-Hosted. I'm the head of developer relations at Tailscale, and as you might imagine, I'm going to talk a little bit today about Tailscale and how to use that to access services running anywhere securely, remotely. So this is the slide that's been up on the screen for the last 10 minutes, so hopefully those of you, some of you have already read the presentation and I can just go home. No? Okay. Who agrees with this statement? Okay. How many of you are Tailscale users, first of all? Oh, really? And you still don't agree with this statement? We've got some work to do. Okay, well, the easiest way to do remote access, of course, is to just open a port, right? I mean, what's the worst that could go wrong? I, though, am of the opinion that port forwarding is dangerous. It's of a bygone era, and it's done now only by people that don't know of a better way. It's dangerous, and you shouldn't do it. Why? Well, firewalls exist to stop people connecting to things on the other side of that firewall. In my case, I'm sat here and I want to connect via SSH on port 22 to my NAS. And my firewall goes, you cannot pass. It's like Gandalf with the stick. And sometimes that's good. But sometimes I do actually want to connect to the thing on the other side of the thing. So I open port 22 of my firewall, and then a million script kiddies find that port like that, and suddenly, why is my internet not working? Why has this box been popped? Because the trouble is, when I open it for me, I open it for everybody else too. So we end up in this wonderful situation. This is live footage from Doge, by the way. So first of all, what is a port? It's kind of analogous, really. If you think about an apartment building, you've got a street address, 123 Evergreen Terrace or whatever it is. Inside that apartment building, you've got apartments. And those have specific numbers so the mailman knows where to take things, and you can drunkenly stumble home with your key and find where you live. And there are a number of these ports available within the TCP/IP networking stack. Some of the more common ones, port 22 is for SSH, DNS works on 53, HTTP on 80, and so on. Anything under port 1024, by the way, is a reserved port and must be approved, I think it's by the IANA, International Association for Number something. You don't want to go to dinner with the guy that thought of the name of that thing. So we've got ports, we've opened things in our firewalls, but they suck. Firewall rules genuinely suck. They don't scale. They become really, really restrictive because you can only, they're sort of like a one-to-one thing. They're not this flexible, they're not software defined or anything like that. They can't react to certain conditions. Maybe if you're paying Palo Alto tens of millions for a special box, they can, but like for most of us mortals running like OpenSense or whoever knows what at home, like it's a static thing that you defined once, and it's like, right, from this source IP, I'm going to now allow traffic to flow when these conditions are met. The other trouble is they must always go to a fixed destination. As I said, they're not flexible. They don't really scale. And by the time you start thinking about, we've only been talking about inbound firewall rules. Lord help you when you start thinking about outbound firewall rules and you turn off your own internet completely by accident and think, what have I done? So who agrees with this statement after that? Yeah, even less. Good, I've done my job. This also creates another problem. I need to know where the front door is of that apartment. I need to know what the apartment building address is, what my physical IPv4 WAN address is. Who's run something like DuckDNS or DinDNS or Cloudflare D or whatever it is, yeah? Yeah? And how often have you tried at some point to log in and it's out of sync? Yeah, it happens. So what about VMs and containers? Do they help? Well, kind of, because we can use firewall rules to target more specific things. We can run things like load balancers and reverse proxies at the end, as the endpoint behind our firewall, but they only do so much. So take this example, right? We have a pretty straightforward example of me trying to access a web service behind a firewall. I then hit my reverse proxy, sometimes called a load balancer. They are different, but for our purposes, they're the same. That traffic then spreads out. It has the permission to go out inside your local network and access the resources and serve the website to you. But they're not perfect. If somebody can still get to that front door, if somebody can still get to traffic and pops that box for some reason, they can do what's called island hopping, and they can then get from that cute little gopher to all of those cute little whales. And the problem hasn't really changed. We've just kind of we've kind of created a new problem by trying to fix the old ones without changing our way of thinking. So, I mean, containers do help a little bit because they create isolation at the kernel level. So rather than having multiple services running under the same kernel with no isolation, you've got a container that's actually basically slicing up what are called C groups within the Linux kernel and dividing processes up in memory. They are efficient. Containers in general are pretty efficient compared to virtual machines. They're not emulating an entire computer. So, like a virtual machine is emulating a CPU, a motherboard stack, a network stack, a disk stack, blah, blah, blah. Whereas a container is sharing all of that stuff with the host kernel, and it's kind of just piggybacking off that stuff. Thankfully, in the last 10 years or so, containers have gotten a lot better at security features, and they're very, very well understood at this point. And with care, I think, for the most part, containers are pretty good for most people self-hosting stuff at home. Even for large enterprises too, to be honest. EKS is a thing, and containers have, 10 years ago you were crazy if you were running a container in production, and now you're kind of crazy if you're not. So I think there's a better way, unsurprisingly. What if we could just ignore the firewall altogether? Wouldn't that be nice? This is like a panacea, right? Imagine if you never had to write a firewall rule ever again. So today's agenda, we've covered why I think port forwarding is dangerous. Hopefully you agree. We're going to now look a little bit at mesh VPNs. And disclaimer time, I am a Tailscale employee, maybe you noticed, or come and talk to us at the booth. So we're going to talk about moving beyond the firewall today. What does this mean? What does a mesh VPN mean? It means that every device can talk to every other device. And this is in stark contrast to the hub and spoke model that we talked about before, where you've got one entry point to your apartment through that front door. Well, now suddenly I've got every single orifice I can enter and exit my apartment through. It might sound like that's more dangerous, but actually it's much more secure. So let's go back to our example here of the firewall, of me trying to SSH into my home server. Using a traditional VPN, I create a static tunnel from my client device. That then connects to a VPN server running somewhere that has permission to tunnel back into my home network. And I send all the traffic through that way, and for the most part, it works pretty well. What happens, though, when I want to add a mobile device, or I want to scale it to 1,000 users? It doesn't scale. So with Tailscale, rather than doing a hub and spoke model, I'm establishing a direct tunnel to the target endpoint. There's no kind of intermediary hub software. And this allows me to not only have no ports open in my firewall, huge security benefit, but I've also got a direct end-to-end encrypted tunnel between device A and device B. Huge win. These direct connections are using something called NAT traversal. A network address translation is essentially a way of making a few IPv4 addresses go a long way. I'm sure you're all familiar with the fact that we've run out of IPv4 addresses for a while now. This is the year of IPv6, maybe. Or is it the Linux desktop? Kind of confused. It changes. So NAT basically allows you to have one public IPv4 address and then have multiple clients on a subnet behind that, effectively, and then those clients talk to the NAT software running typically on a firewall, and they figure out a bunch of stuff in the firewall called stateful firewall stuff. And when those devices make an outbound connection, the stateful firewall remembers that connection and then says, well, if something comes back on that port, I'm going to allow it in for the next 20 seconds. And it's a really secure way of doing it. And Tailscale uses something called stun, which if anybody sails the 7 seas and uses BitTorrent, you've probably seen stun servers before because they're in every torrent client. That's how they do the discovery. So we use the stun protocol to do discovery from our control servers, and then that handles the mapping of NAT addresses to UDP ports. These direct connections allow any device to connect to any other device, no matter of the network topology that's in the way. So it doesn't matter if, for example, does anybody here rely on Starlink for their daily internet needs? You lucky bunch. My good friend Brent lives up in the Canadian mountains, and he relies on Starlink for his personal internet. And we're on a Zoom call, or I was going to say Skype. It's a bit out of date, isn't it? A Skype call, and he'll just disappear for 30 seconds. But the trouble with Starlink is they do something called carrier-grade NAT. It's the same thing that happens with your cell phone. You couldn't run a web server from your phone because you don't have an IPv4 public WAN address. You've only got a carrier-grade NAT address, which is really effectively just a LAN on the carrier side, and then the carrier has a pool of IPv4 addresses that they'll allocate to kind of like a node that is responsible for those downstream clients. Okay, so if you want to learn more about NAT traversal, I highly, highly recommend taking a look at this post. It's a couple of years old now, but when I first started at Tailscale, I learned more than I thought I didn't know how much I didn't know until I read this post, basically. Go read it, you'll learn a ton, and it's a really good one. So we're going to talk now a little bit about running local services. Look at my humble home lab, sat in the basement. This is my temporary server rack that I built 7 years ago when I emigrated to North Carolina from London. I don't know if you could tell, but I'm from London originally. And it's just some 2x4s screwed together from Home Depot. And I swore it was going to be a temporary thing. But now it's still in production. It just does the thing, despite half of the internet telling me it's going to catch fire because it's made of wood. So far, so good. Who here does self-hosting? Hooray, I'm amongst friends. It's fun, isn't it? You get to own your own data. You get to lose your own data. In fact, I don't know if anybody's seen my latest YouTube video talking about this, but this presentation actually nearly didn't happen because my Nextcloud instance is running on, well, it's actually on that hard drive in that box right there. And this was last weekend. And it's running Nextcloud, and I didn't have a copy of the presentation locally, because when I submitted this was like 3 months ago. And I've had a new laptop since then. And so not only do you get to own the data, but you get to own, so when it goes out, basically, you're not calling Google or anybody else, you're on the hook to fix it. So both a bug and a feature. One of my favorite aspects of self-hosting, though, is that you get to build a solution piece by piece. You get to craft a solution. You get to select your tooling, make decisions based on your personal, beliefs, I suppose, your risk profiles, your technical expertise. A bunch of things go into the decision of choosing, let's say, Nextcloud over cFile, for example. And over time, you will assemble a stable of software that means that you never have to worry about some of this stuff ever again. Well, until your server blows up, but that's part of it. The single biggest reason for me and why I really, been doing the podcast for so long now is that there is no business model to feed. How many times have Google canceled products on you now? How much longer are we going to accept that as being the status quo? I know right now Google Photos is kind of free-ish, but that's not going to last forever. And you can use self-hosted software like Image, which is a self-hosted photo and video management platform, to replace Google Photos. Now, what happens if the Image team stops developing Image? Well, you've still got a functional product as of today, and you will have that code, because it's open source, until the end of time. Should you wish to fix a bug, should you be capable, you can. Good luck trying to fix a bug with Google Photos. Same thing's true with Jellyfin. That's analogous to a Netflix or a Paramount Plus or any of the plethora of other streaming services that are proliferating these days. Another one of my favorites at the top here is this Libre speed. I actually use this to test when I run a new cable in my house, for example. A couple of weeks ago, we're having our attic turned from a dusty, dust bowl where it just collects pollen dust. We're having that converted into a studio space for me. So I ran a fiber from the attic to the basement. I'm like, well, did it work? I mean, I don't want to do iPerf or anything like that. So I just literally plugged in a 10 gig adapter to my laptop, pulled up Libre speed, ran the test, and I got 10 gig down, 10 gig up, and I'm like, sweet. Nothing left my LAN. I didn't have to worry about speedtest.net and throttling and prioritization of the WAN and all the rest of it. That's even presupposing that your WAN can do 10 gig, which mine can't. Then there comes the juggernaut in the room. Home Assistant users? Oh, a lot of you are missing out. Home Assistant's awesome. Okay, Home Assistant pitch time. You have a Philips Hue bulb in your life, right? Then you have a coffee pot, maybe some smart blinds, maybe some other lights or something, I don't know. How do you connect all those disparate ecosystems together? You can't make a Philips Hue bulb talk to your Craig coffee pot, or Keurig coffee pot, can you? Well, with Home Assistant, you can. Because our Home Assistant has a bunch of plugins that pulls all of these disparate random IoT things into one place. And because they're in one place, they can react and they can talk to each other and then they can start to actually build a smart home instead of just a sort of kind of worse version. When I first emigrated, I will always remember, I went to Best Buy the first week I was here and bought a Google Home and a Hue string light for the guest room. My mother-in-law came to stay, and she was like, hey, G, turn off the lights. Nothing happened. And I heard it through the wall a second time. The third time was full of expletives. And it was in that moment I realized I had to design my smart home not just for me, but also for guests and other people and other humans to actually use it too. And with Home Assistant now, I've got the ability to have a mother-in-law is in the house mode. I can literally just say these light switches don't work physically except at these times, and so really you can get as granular as you want. It's all written in YAML. And I actually just on Reddit last night saw somebody who's developing an AI agent that will help you go through all of the entities in your house and say, hey, by the way, did you know these things often turn on and off together? Did you want to put that in as an automation? Because it's open, because you're in full control, not only of how the devices connect to each other, but also of the underlying Home Assistant code base, you can do some really cool stuff. So those of you that didn't raise your hands about Home Assistant, please go check it out. It's free. It's an awesome, awesome project, and I think you'll have a really good time. Now, some of you might be thinking the barrier to entry seems really high. Perhaps the self-hosting world is just for people with neckbeards and bodies such as myself. But actually, it's really easy. It's just a few lines of YAML. Really, that's all you've got to do. So this is a snippet of a Docker Compose YAML file. This defines an app called Audio Bookshelf. This is basically a self-hosted alternative to Audible. Now, I pay for my audiobooks, always have, always will, because I think authors deserve the money. There's a contentious argument to be had about film studios and the media business in general, but I think written stuff and books and things is a separate category, and it's still a little more the author still sees more of the cash, even if I buy it through Audible. What I don't like about Audible, though, is it's full of DRM. So if Jeff Bezos decides to change the business model on me, remember we were talking about feeding business models a few minutes ago, if Jeff decides suddenly, let's say I stop paying for Audible subscriptions, and then I lose access to all of the library that I've acquired over the last decade, that doesn't seem right. All this stuff that happens in the media right now about acquiring licenses to things rather than actually owning stuff, it's not for me. So I use a program called Inaudible to download the AAX file from Audible, strip the DRM, and then put it into Audio Bookshelf. As far as my wife can tell, the interface looks just the same. She can pause and sync between different devices, and it's awesome. So when my wife goes to audio bookshelf, abs.wd.ktz.me, that's my personal domain, what happens? I'm going to talk through the anatomy of a web request here, so sorry if I'm teaching anybody how to suck eggs, but I thought this was pretty interesting, actually. So first of all, your device makes a web request. Where does that request go? Well, step 2 is that it goes to a DNS server. In my case, that's a Pi-hole. Once the domain name has been converted into an IP address, step 3 on the client then goes out through the firewall in step 4 and creates that outbound NAT port mapping that I talked about earlier. The destination firewall then matches that traffic to a rule set that says, well, I'm going to allow traffic in on port 80 or port 443 or whatever it is. And then it's going to hit a load balancer or some kind of a reverse proxy or some resource or some kind of traffic direction mechanism that has permission to reach out inside the network you're trying to connect to grab the resource that you want. So in this case, step 6 and 7 happens on the remote side. Finally, step 8, that content gets returned back to you and you start playing your audiobook. Now, there are some specifics to be aware of with setting this kind of thing up. You've got to try and make sure, at least I'd like to try and make sure that this stuff works whether I'm around or not, whether Tailscale's around or not. And so I set up my local DNS server in each location. So I have my house at home, I have my mother-in-law's house, and I have my dad's house. And I run a Pi-hole in each of those locations for them. And then I use split DNS to be able to access the services running in each place remotely for myself. But I also want the people in the remote subnets to have no idea that that's possible. I want them to just think, oh, I type this thing in and it just kind of works. So running a local DNS server in each network, which is then reachable over Tailscale, means not only I can administer that stuff remotely for friends and family, but also it will keep working for them regardless of whether I'm here or not. So I kind of thought when I was writing this talk, like, what is the most cursed thing I could come up with? And for me, it was, well, why don't I put step 6? Why don't I put between step 6 and step 7? Why don't I put that over Tailscale? So rather than having caddy reverse proxy over a local IP address of 10.42.1.10, why don't I have caddy reverse proxy over a tailnet IP instead? And this way, I can run a reverse proxy in my house, but have it reach out to a back-end server, or whatever it is, over the tailnet. Fully encrypted, remember, end-to-end device direct connections, all that good stuff. So now I can actually access the front end of my mum's Synology from my local network without having to run that DNS server in her network too. So I'm always trying to simplify and trying to figure out ways to make this better. But essentially, that was the most cursed thing I could think of, was why doesn't the reverse proxy reach out over Tailscale instead? Okay, we're at the Magic DNS stuff here. So Magic DNS is Tailscale's way of giving devices on your tailnet a fully qualified domain name. So rather than having to remember specific IP addresses, you can just type the name of the node, for example. You can use split DNS to route arbitrary requests wherever you would like. So you can see here, for example, I've got ktz.ts.net, I've got gg, which is Goldgate, where my mother lives in England. I've then got git.ktz.me, which that actually resolves to my local Pi-hole, and then another, it's just like turtles all the way down. So no matter where I am, I can resolve these domain names, and instead of having to route things through 20 different spots, like, this just makes it simple for me. Okay, this is probably the most dangerous part of the entire talk, because I added it this morning, and it also requires network connectivity, so fingers crossed. If you are already a Tailscale user, has anybody actually ever used this apps button before? Just one person. 2 people.
I've looked at it.
You've looked at it. Yeah, I've been working there for a year and a half, and I've looked at it too. Until last week, I was like, what does this thing do? So I'm an expat, right? I live in America now, and I still really miss BBC iPlayer. Now, I'm not going to advertise geo blocks and circumvention stuff, because it's like Fight Club, right? You don't talk about that stuff. So what we're going to do is we're going to look at IP Chicken as a website. What you choose to do with this information, it's up to you. So what we're going to do is we're going to configure an app connector for a target domain, in this case IP chicken. We're going to advertise on some remote infrastructure. We're going to advertise that as what's called an app connector. And then using the Tailscale access control rules, we're going to route traffic over Tailscale, but only for that specific website. So IP chicken, instead of saying my current IP address, when I'm connected to my tailnet, it will route that traffic out over the tailnet to England and come out in England. Okay, wish me luck. I should probably mirror my displays, right? I didn't do that beforehand. Whilst I mess about with that, are there any questions at this point? Because I'll be a minute or so. Good. Okay, how's that? Good stuff. All right. So, okay, here I have an Ubuntu virtual machine running on top of DigitalOcean. This is running in London. Now you can note the IP address here of 104.248.165.82. So let me turn off Tailscale. And if I go now to IP chicken, this is my current IP address. That was really fast. Cool. But if I turn Tailscale on, it's not configured yet, so it's not going to work. But I told you I only did this morning. I haven't rehearsed this bit, so there you go. We need to configure the app connector section here. So there's a bunch of documentation, which we're not going to go through step by step, because I've done some of the prep already. But essentially, when we click on this apps tab over here, we want to, let me make that bigger, we want to now tag some of our infrastructure to be what's called an app connector. And you can kind of think of this like split DNS, but for a specific website. It's useful if you've got an enterprise GitHub or something, and traffic has to originate from a specific spot, like enterprise security teams like to whitelist specific stuff. I like to use it for iPlayer, like I said. So let's take a look at what's involved in creating one of these things. Not much, thankfully. We put in a name, which could literally be anything you like. We then use we then put in a domain name, so in my case, IP chicken. And then we need to do what's called selecting an ACL tag. Now I've created a tag here called UK connector. So how do we apply that to a specific situation? Well, first of all, in the access controls tab, I need to create this tag connector here. It's only 3 lines of code, so I think we can probably manage that. Once that's done, we'll go to machines, and I will find in here, this is the Prez, this is the same instance that was that QR code at the beginning. That's what's hosting the presentation that you all looked at. I can now go in here and do what's called edit ACL tags, check the box, and I'm now going to advertise this as a UK connector. This is because on the back end, let me make this a bit bigger for you. Did I disconnect from Tailscale? No. Oh, I changed the name. Yep. I'm going to connect, and I'm not, apparently. There you go. This part of the demo is not going to work, but hopefully the end result will. So if we go back to the apps page, you can see that now IP chicken is going to route all of its traffic through the Prez domain instead. So now, hopefully, when I refresh this, this page, it's going to pull down the new routes from Tailscale, and suddenly, look at that. All of my traffic is now being routed through that DigitalOcean droplet. You see, was it 165.82? 165.82. And so if you were to get the right incantation of specific news websites that you visit, banking websites that you visit, content websites that you visit, for example, Lobsters RS is currently blocked in England. If you wanted to come out in America, I think it's still available, You can do that kind of thing using app connectors. And this is just one example of the flexibility of Tailscale. You've got direct connections on infrastructure that you own. So this is just running on a droplet that cost me $8 a month. This could just as easily be a Raspberry Pi that you chuck under the stairs at your mum's house and never worry about ever again. As long as it's got internet connection, Tailscale will find a way to connect to it. Okay. Any questions on that? Because I know that wasn't perhaps the clearest demo, but... Yes.
I just have a clarification question. It looks like these are either route or application-specific exit nodes. Yes?
Yes.
Gotcha.
App or app? What did you say? App-specific URL-specific exit nodes. Yeah, exactly. That's exactly what they are. That's an even better way of putting it than split DNS for certain things. Can I steal that? Hi, Mike.
Hey, your first load, you got the DNS error. I use the app connector a lot, and I always seem to get that DNS error on my first load.
Yep.
Is that a known issue? Is that, what is,
Well, it's because typically the first load is pulling down the new rule set from the control server. And that can just take a beat to happen as it's, because each Tailscale client is running a fully local DNS copy of all the rule sets. And so when it's doing a device lookup, it's not going to Tailscale, it's just happening locally. So if the Tailscale control server goes down, I'm not sure I'm allowed to tell you this, but every time we deploy Tailscale, we take Tailscale down for a minute or two. And then most of you probably never noticed, because all the stuff is happening locally.
and DOH was a real nightmare to figure out, but turning that off makes it work a lot better.
Yeah, and the other situation where it can get a little hairy is like captive portals, if you've got Tailscale turned on, because that's messing with the DNS, and then the captive portal's expecting a certain thing, and yeah, just, it's always DNS, right? So if you want to find out more about Tailscale, I make a ton of YouTube videos for them. Obviously, I've got the self-hosted podcast, but also what pays my mortgage is, the Tailscale videos. I tend to try and do as much home lab stuff as they'll let me get away with. So I've got a really interesting video coming up in the next couple of weeks about NixOS, self-hosted AI with Olama, and NVIDIA GPUs, and how you connect it all with OpenWebUI and that kind of stuff. So go check it out. This is, again, where you can find me. And I think it's time for the big reveal. So that QR code that you all had at the beginning, right? I think I already gave this away, didn't I? But that's actually running on that DigitalOcean droplet with the firewall completely closed over Tailscale using something called Tailscale Funnel. So you can use that one command to actually host websites. So let's say you're a developer and you want to share just a quick prototype with someone. You can do Tailscale Funnel, port number, and it's on the public internet. Obviously, that can be incredibly dangerous if you, like,
So it's basically like ngrok built into Tailscale.
yeah, it's just like ngrok, but built into Tailscale. Yeah, absolutely. So I think that'll do us. So yeah, please, lots of questions. I would love to do a bit of a Q&A and sort of answer questions about self-hosting. It doesn't have to be about Tailscale. It can be about anything you like. So.
How do you handle high throughput or applications that need a lot of bandwidth, like backups or stuff that's constantly running 24/7 remotely across the ocean?
Well, funny you should ask, because when I emigrated, I left my old server in England. And then when I got here, I built a new one, because American tech prices are awesome compared to Europe. So I replicate roughly 20-ish terabytes between my server in the basement, although I realized I missed an Nextcloud data set this week. That was actually quite a scary moment. But because Tailscale does direct device-to-device connections, the performance is pretty good. So across the ocean, I typically see somewhere in the region of 40 to 50 meg. I've got, as of about 6 months ago, 5 gig symmetric fiber at home. I was really excited for it to run at 5 gig symmetric. However, the encryption overhead of WireGuard is single core bound. And so you run in, when you're trying to throw that much data over a wire, you actually gain quite a lot of performance by doing like multiple threads. So you have like a TMUX window open or something and do 2 or 3 streams, and that can take you from 50 to 100 to 150, just like that. Yeah, looks pretty good.
The problems are always DNS. I've got Pi-hole that I connect to back at my house. If something doesn't load on my phone, I turn off Tailscale, turn it back on. Usually it works. And then if it doesn't work, I just restart Pi-hole and it usually starts working. What is going on in the background, on, say on a phone, when I'm turning off and turning back on the app? it kind of resets the cruft.
Probably that. I mean, you've seen the IT crowd, right? Yeah. So when you're turning Tailscale off and then you turn it on again, there are a bunch of caches that get cleared. It also forces the phone, or whatever it is, to pull from the control server the latest, freshest version of everything. It's like the most up-to-date routings, for example. Because of the NAT traversal stuff, you can't necessarily guarantee that all the clients are where you left them. This laptop, for example, is in LA today, whereas last week it was in Raleigh. And if there hasn't been a sync happen for whatever reason, sometimes those things can get a little bit out of whack. Turning it off and on again, as cliche as it is, just forces that sync to happen.
So I've been happily self-hosting with the, what you would call dangerous, port forwarding, reverse proxy, dynamic DNS mechanism for well over a decade. Knock on wood, I haven't had any problems. I do share your concerns that it does open you up to, dangers, that you would not have elsewhere. My question for you is, there are some services that I get great benefit from being publicly accessible, right? For example, my Nextcloud instance. It's nice to be able to share links with other people, say if I'm traveling with somebody and I want to share photos. Or it's honestly my disaster recovery plan in case I lose all of my devices. I can log into my Nextcloud and get my password database and get access to everything. So is there a mechanism, if I was, now I can see the benefit of using Tailscale for services like Home Assistant, for example, where, currently I have that publicly accessible and it kind of weirds me out a little bit, and, I can see the benefit to locking it down. Are there mechanisms within Tailscale for saying, I do want some services to be publicly accessible? Is that a thing that you can do?
I actually hid a bunch of slides because I decided that wasn't that interesting, but this is going to answer your question so perfectly, I think, that I've got time, I think, right? How long have I got? How long? Oh, really? Wow. Okay, well, we'll definitely do it then. So you can kind of abuse CNAMEs to do this, right? So a CNAME is a way to kind of hack DNS a little bit to point something at something else without it actually being an A record. So what you could do is you could put a CNAME into a public DNS provider pointing to a Tailscale node inside your network. So that's what this looks like. For example, I've got a Caddy reverse proxy, which you can see is running on the Velociraptor Noodlefish Tailscale net DNS name. And I do a wildcard entry for star.rdu. So whenever I go to RDU, or like audiobooks.rdu. Whatever the domain is, underneath, that's then going to try and route itself to a Tailscale domain. The clever part comes when you're running Caddy on a publicly available server. So let's say you put Caddy on a VPS. Do I have a picture of this? No. You're running Caddy on a VPS, and you have it in front, you have a real domain name of tethix.something, I don't know, audiobooks.tethix.com or something. And in the background, that's then resolving the CNAME, because that node is on your tailnet. It then tunnels back to wherever that resource is and goes and fetches it. So the front door is moved, effectively. You're not doing port forwarding. The front door is now still on the public internet, but it's kind of obfuscated a little bit by this mechanism using CNAMEs. So if we look at this example here, for example, if we use dig, you can see that the CNAME here of test.rdu.dotsandstuff.dev actually resolves underneath to a Tailscale domain, which then means I'm able to route whatever I want behind that wildcard of RDU something to my LAN. So that lets you use real domain names if you want to, like I said, the stuff that you own, because you can just use Caddy's built-in Let's Encrypt support to get a certificate for whatever domain name you want to, and should be good to go.
So just to confirm, there are like ts.net addresses that are publicly accessible. It's not just a internal have your device on Tailscale.
Well,
For
you
all
can use Tailscale Funnel to put something from anywhere on the public internet, and that will be on a ts.net domain. The downside of Funnel for that specific scenario, Nextcloud, for example, let's say you're dumping a bunch of photos, it's quite a high bandwidth scenario. Funnel uses a piece of Tailscale infrastructure to proxy all that traffic in and out, because then that traffic has to go through a front door somewhere on the public internet, right? But by you spinning up a VPS and doing this CNAME trick, you then become the owner of that front door. So you're not subject to any quality of service restrictions we put on the funnel traffic that comes in and out. Also, you can then choose a provider that's geographically best for you, and right, there's just a lot of reasons to do it yourself. Like you put some craftsmanship into figuring out the best route for all the traffic. So the answer is yes, it does involve a little bit of work, and I would love for Tailscale to support custom domains. I've heard rumors it might be coming, but I heard that a year ago too, so watch this space.
Thank you.
There's a lady down the front here. Do you still have a question? She's busy in her program.
Actually, my question was because I didn't understand what you're saying. So I was curious, what did you do with that, your mother-in-law's in your house and somebody else, you were able to go through some kind of DNS? What were you doing, by the way? I was just curious. I'm sorry, I missed that part.
That's okay.
Can you go back to that slide you were doing, which slide?
know where it is.
Remember. The one that you said you set up the, is it Pi-hole you did? I can't
Maybe.
remember.
I can talk you through it though.
It's a slide right before. I think that's
This one?
No, not that one, but the one that you, I don't know which one.
Up
but
or down? Up or down? Which slide? I can't remember.
Oh,
Yeah.
yeah, right, exactly.
So the idea is, I want each network that I kind of administer, my parents being one of them, to be fully self-contained. So regardless of whether I am involved with it or Tailscale's working or whatever, like, I don't want the DNS requests to be going across the ocean every time. Number one, performance would suck. And number two, it's just a layer of complexity that I don't really want to be dealing with. My mum texts me saying, Alex, the DNS is down at, well, for her it's 7 a.m., for me it's 2 a.m., you know? So what I wanted to do was find a way to kind of treat each site as a unique, like an isolated entity.
Okay.
And by putting a local DNS server in each place, it allows me to have that fine-grained control of just having a DNS wildcard pointed to that site. And then for me, I can just run a reverse proxy on that network, and parents are none the wiser. Does that help?
Yeah, that's nice. Okay. Yeah, that was just something I wanted to know a little bit more. Thank you.
You're welcome.
Infrastructure, Ansible, Terraform, Nix. What are you using to manage the whole infrastructure?
Yes.
Yes, and yes.
My home lab has several non-negotiable pillars. One of them is Proxmox. Another one is Ansible. Increasingly NixOS, although not completely non-negotiable because it's a pain in the ass, honestly, sometimes. Docker, and then some form of config management. And I use different strokes for different situations. So I'll use Ansible to manage my Docker Compose files, pretty much exclusively now, actually. So what I do is I create an Ansible variables file that has basically the outline of a Docker Compose file, run that through Ansible, and it will inject all the secrets into the Compose file and then copy it to the remote host. So I've got all my secrets stored encrypted in GitHub, and occasionally I forget to encrypt that file, and my infra repo, I don't know if I can show you this. I don't know if the Wi-Fi will help, but every time on my GitHub repo, this is where all that code lives, by the way. You see this 99.7? Used to be 100%. Every time it iterates down I forget to encrypt that file, and there was one moment where where is it? Is it in group vars or something? I forget where it is. But I got an email on my phone from Google saying, your Google password's been exposed. I'm like, oh, because that connects everything. And the best part was, that was when I was using SnapRaid to do like media server stuff. I don't use SnapRaid anymore even, but there was like a program called SnapRaid Runner that used to send me email alerts. I wasn't even using it anymore, so I still have my Google password in this massive encrypted variables file. But I use Terraform to spin up things like Kubernetes clusters for videos for work and stuff like that, like a couple of commands here to just use the Terraform providers to spin things up here and things up there. Really, I view my home lab very much as a tool for educational purposes. I think, like, what direction is the industry going? Well, right now, of course, every buzzword, every paycheck is every VC check is going towards AI right now. I also have a personal interest in NICs, and so you think to yourself, well, how can I make myself more relevant going forward in the marketplace? How can I, how can I keep my content interesting to people and keep them listening to the podcast, make interesting videos for Tailscale? It's like, well, just do stuff that other people aren't quite doing it and figure out how to connect a few dots together. And for me, that's what a home lab represents, really. It's a playground where, for the most part, I can break stuff without too much consequence. And so you end up making a bunch of decisions about like separating physical hardware and like, do I put Plex on the same box as I'm spinning up those virtual machines that can break stuff? No. I end up having like a pseudo prod at home, which runs Plex and the R stack and all that stuff, along with Home Assistant. And that box is called Neo, because it's the one box that must be up all the time. Because if that one goes down, my 4-year-old will tell me in about 3 seconds that, Daddy, I can't watch Peppa Pig. Whereas when my Epic server goes down, there are situations that require specific pieces of hardware, like GPUs for LLMs and that kind of stuff. And I just want to experiment. And occasionally, as you saw in that thumbnail, like I break stuff, and it's the reality. And every time something like that happens, like I tried to log into my Nextcloud to download this presentation, and I couldn't. I'm like, I need to change the way I'm thinking about this, because like the home lab should not have any critical infrastructure on it. Okay, maybe the GPU part, I can kind of get away with putting that as being like on that box, but the actual core of Nextcloud, the core of image, should probably be on Neo, right? And it's just, you can then apply those lessons at work. In my interview processes for my last 5 or 6 jobs, I've referenced my home lab. And originally I was talking about Unraid back in the day, and then I matured onto doing it with native Linux, and just the skills I've picked up in that environment make me sound like I know more than I do when I get to an interview. Really. That's it. So, got one down the front. In front of you.
I think I've heard you mention before about using Tailscale, like sitting right with a container for the like one application in a container. How does that work?
So are you talking about Tailscale sidecars, like with Docker?
Probably.
Yeah. So, Tail Docker. No. I'm on the wrong tailnet, so I can't currently reach my self-hosted Google replacement. But essentially, there is a whole bunch of documentation with my ugly mug over it for Tailscale. I also wrote a massively long blog post last February talking about how to do this. So, when I find the right code snippet, there we go. Essentially, if you want to put a container directly onto your tailnet and get all the advantages of having that direct device-to-device stuff, even having containers talk to other containers over Tailscale. So for a good example of that might be you've got Prometheus wanting to scrape a Kubernetes cluster on the other side of the world, and you've got pods moving around doing whatever they do and all the rest of it. If you define a sidecar in that kind of Kubernetes world, or in this case, this is just Docker Compose, you can actually merge the kernel namespaces in the network realm of those two containers together, such that they've still got individual user spaces, so each of those binaries are operating in their own fiefdoms, but the networking namespace in the Linux kernel that was sliced up for those two containers because of this line here, network mode service, whatever, which, by the way, matches the name of the service in Docker Compose, you merge the networking namespaces together within the Linux kernel. So if you were to do like a netstat or an nsenter or something like that and list the ports that are running in those two containers, they'd be the same because they have the same network namespace. And so really it's just a case of supplying the correct environment variables authentication keys, and storing the state directories in the right place, and you should be good to go. Does that answer the question? Yeah, thanks. Thanks, GMB.
Which service do you use for your home lab backups?
I don't use a service. I have a friend in Canada called Producer Steven, if you listen to self-hosted. And we actually racked and stacked an entire server for Jupiter Broadcasting. So he runs an MSP, service provider in the local Ontario area. I'm aware Ontario is an entire province, but anyway, north of Toronto. And he was building out a room, and he's been listening to the podcast for ages, and he reached out, and he was like, I've got 4U of rack space. Do you have a server? Do you want to just throw a server into my room? I'm like, heck yes, I do. So now I have a server in Toronto, effectively, that I have full control over, that has about 6 disks in it with ZFS, and I can just send everything there. I've still got my old UK server, remember, so I've got stuff in England too, and I replicate everything to Ontario and England. And then at my mum's house, I've got an old Synology where I send a bunch of stuff as well. None of those places had the Nextcloud data set. So I've learned some gaps today. But if you were going to be using a hosted service, there are some pretty good options. Has anybody here heard of ZFS.rent? It's about to change your life. You can send them a hard drive. I think it's like $10 a month. So if you go to Best Buy and buy a 20 terabyte hard drive, you can send that, you can pre-populate it with your data locally, send it in the mail to them. I think they're on the West Coast, actually. And then they'll throw it in a server for you for $10 a month. There's some bandwidth restrictions and stuff like that, of course, but if you've preceded the disk, you can get over a lot of that stuff. And it's by far and away the cheapest way to store 20 terabytes worth of data in the cloud that I've come across. You can do other stuff like Backblaze. That's another good option too. A lot of these players come and go over the years because unlimited storage isn't really unlimited, and bandwidth fees go up and down and all the rest of it. So you can't ever really truly beat owning the backup targets. Like I said, I own the data, but I also own the outages, so that kind of sucks. Example being, my UK server a few months ago decided it wasn't going to boot anymore. So I had to call up a friend from uni that I hadn't spoken to in about 6 years and say, you live 10 miles from my mother-in-law's house. Would you mind just going and seeing what's going on? Turns out the power supply had died in this box. No wonder, it was like 15-year-old power supply. And then I said I had to overnight a power supply from scan.uk to my mother-in-law's house and then buy this guy a case of cider to say thank you. And it was nice in a way because I rekindled a friendship. But it's not like a service. There's no SLA. Right? Like that box could have been offline for years until I next went to England, and who knows when that's going to be at the moment, you know. So, very many answers to a very simple question. I tend to do that a lot on the podcast too. But the thing is about self-hosting is it's full of nuance. Like everybody's problems are different, and all you're doing is selecting a bunch of tools. Remember I talked about the craftsmanship of building a solution? There are trade-offs to every single one, and in my case, the remote hands piece of it was a big negative when the power supply went out, but up until that point, it had been nothing but positive. So it's like, now I'm aware of that trade-off because I've lived that experience, you know. So go forth and self-host and lose some data from time to time.
The extra warranty you think is worth it now, right?
Oh, you're talking about the Micro Center trip. Yeah, so I don't know if you care too much, but I just built a new server around a Threadripper Pro, and I went to Micro Center for the first time ever. What a shop. I am so glad. So the nearest one to me in Raleigh is in Charlotte, which is about 3 hours away. It's probably good, because otherwise I would probably be homeless. Because that store is they've got 3D print. You've all been to a Micro Center, right? Yeah, it's like Mecca for me now. But yeah, the sales associate, I was buying a Threadripper Pro CPU for like $900 or something, and then a motherboard for $1,000, and he was like, do you want to spend an extra $300 on the service plan? And I was like, nah. And then he taught me through the benefits of it, and I was like, well, if it breaks in 2.5 years' time, you can bring it back and we'll give you store credit for the exact amount you paid today. And I'm like, it'd be a shame if that happened, wouldn't it? I'm not going to commit fraud, don't worry, but It's just, I could see some people would. It's just nice to have that peace of mind. Part 2 is coming out next week, by the way. The motherboard didn't fit in the case. So there will be a part 3. Yeah. You could go and buy a banana 2x4 from Home Depot instead, yeah. Yes, sir.
What was the name of that service that you send a hard drive to
ZFS.rent. I have no affiliation, but I have spoken to the guy a couple of times. He seems pretty nice. Their pricing is just really quite unbelievable. $10 a month per hard drive. All that you have to do is buy the physical disk. Yeah, it's pretty sweet, yeah. Go compare that to rsync.net or something, and you'll see why it's such an unbelievable price. Any more?
Does ZFS.rent work with ButterFS subvolumes?
What do you think? I don't know, actually. You'd have to email him. I think you get a shell to a remote session. I'm not sure. I know, for example, that rsync limit very specific subsets of commands you can run against the data sets. I'm not sure how secure ZFS.rent is in that regard, so maybe. But are you running ButterFS in sudoprod? Yes, on my home. And you still have hair too. I mean, that's. No data loss for close to 10 years. So when are you switching to bcachefs then? Yeah. Yeah, I don't know. There's something about ButterFS. I mean, it's part of the kernel. I mean, that's a big plus over ZFS, of course. But I don't know. Why can't I trust it? Like, I just can't seem to. Maybe. Okay. I do mirrors with ZFS, at the minute, so should be fine, huh? I suppose Facebook have spent a lot of money on ButterFS since a decade ago. But fast systems have exactly one chance to screw me over, and ButterFS did, so maybe that's why I don't trust it. Any more? Pretty much bang on time, I think, so thank you.